For years I've used the Sound Blaster Audigy FX version 2 sound card in my computer, but it kept failing because I think it's too close to the heat generating video card in the computer, so I decided to switch to an external audio interface for the computer, and at the advice of my pro audio dealer, I selected the solid state logic model SSL2 Mark II, which I'm using to do this narration through. I should clarify that I'm not using the older SSL2, nor am I using the SSL2 Plus. I'm using the SSL2 Mark II, that particular variant of the product. This is essentially a stereo input, stereo output device, and I'll go over all the details of it by way of my overview. But essentially it replaces the old Sound Blaster Audigy FX card, albeit with more analog input and output options, such as having the ability to have a good mic preamp on each of the two channels and be in a mono or stereo mode, and some other bells and whistles. First, what comes in the box? First off, the SSL2, as I'm going to call it, is powered from the USB connection to the computer. It does not have a separate power supply. It does not plug into the AC mains. It does not plug in through a wall wart power supply. It is completely powered over the USB connection, which is nice. It comes with a medium length, I would say several feet long, USB cable with USB Type-C connections at each end. And indeed, the jack on the back of the SSL2 is a USB-C type socket. Now, on the other end of the cable that's included, while it's USB-C, because so many computers have USB-A, the classic USB connector, they include a little adapter, as is shown in the picture here. Apparently some versions of this actually come with two separate cables, one being USB-C to USB-C and the other being USB-C to USB-A, without using the adapter. Either way, you're covered for choices of cable. There's really nothing else in the box besides the SSL2 itself and the included USB cable and its adapter. There's no manual in the box. You have to go to their website and pull it up there. By the way, it's kind of a pain because you pretty much are forced to create an account and log in order to gain access to things like the manuals, the driver, any additional software they have, any of that kind of stuff. They pretty much force you to create an account, sign in, register the product before you can get other things. I'm not fond of doing it that way, but that's the way they've done it. Just a quick word about the different models. The SSL2 Mark II is obviously the newer version of the older SSL2, but there is a 2 and a 2 Plus. So currently available is the SSL2 and the SSL2 Plus, both with the Mark II at the end of them. The main difference is that there's more inputs and other analog devices coming in and out on the Plus version, and there's also MIDI in and out jacks. They don't recommend that you get that version, in other words, the Plus version, unless you're doing collaborative work where different workstations might be plugged together like this. If you're just working in isolation by yourself, there's no reason to get the Plus version. Just the regular SSL2 would work. I forgot to mention that the SSL2, its USB is USB 2.0, so it doesn't require anything fancier than that to work properly, but it requires at least that rating on your computer, which shouldn't be a problem with any current computer people are likely to have. Anyway, it is USB 2.0. Now, getting on to the dimensions, I'll start out with that. It's approximately 9 inches wide at its widest point near the rear. It's about 6 inches from front to rear, and it's about 2.5 inches high from whatever you're setting it on up to the highest point on the unit, although it's possible that the big monitor volume level knob might stick up just a little bit higher than that 2.5 inches, but that's essentially the height. All right, let's take a look at the, I guess I'll call it the front panel, because this thing is sloped back like a mixing board. You basically have a choice for each of the 2 input channels, which are essentially mono, but they can function as mono or they can function as left and right stereo. Each of those 2 channels can have a so-called instrument input, for example, coming from a guitar or an electric bass or something like that. It can be a line level signal, coming from a synthesizer or, the output of some other piece of audio equipment. And it can be a microphone input, balanced input through an XLR connector. The only ones that are on the front are the ones for the instruments, and you can see them here at the left, the instrument 1 and instrument 2. Instrument 1 is associated with channel 1, instrument 2 is associated with channel 2, which are the ones that are more or less above them on the top panel. There's also 2 pairs of headphone jacks. These are your standard 1/4 inch phone type plugs, stereo tip ring sleeve types, and they claim to have an especially powerful output circuit driving them, so there's no problem driving any type of headphone and at very good volume levels. There is only a single volume control knob for those 2 jacks. You cannot adjust them independently. Here's the rear panel. At the upper left is the USB-C socket, which is how the unit is powered and also how it communicates with the computer. And then you can see the 2 outputs. They're marked left is actually on the right in this view, and right, which is in the left on this view. But that keeps them in line if you're looking at it from the top, with left essentially being everything on the left and right being everything on the right from front to rear. These are 1/4 inch phone style tip ring sleeve. So they're set up for balanced outputs. They're line level balanced via, again, the 1/4 inch jack. According to the tech support at SSL, but not mentioned in the user's manual, is that it's okay to plug in a regular tip sleeve phone plug. In other words, one that does not have the middle ring. It's okay to plug those in here. It will not damage anything. They're designed to be able to work with regular tip sleeve type or TS type plugs if you're not using the outputs in a balanced way, if you're using them single-endedly, in other words. But they are line level. The other devices that are on the rear are the 2 combinations or combo jacks, here labeled number 1 and number 2. These can accept a 1/4 inch input. They can, in other words, a 1/4 inch phone input that just plugs right in the middle, and then you can see where there's the 3 smaller circular slots to the left, to right, and on top of the main central jack, and that is to accommodate XLR connectors. So in one connector, it's both a 1/4 inch and an XLR. I'll talk more about the way those are used, but it has that type of jack. All right, let's take a look at the top panel. You can see the channel 1 section on the left, channel 2 section in the middle, and then the output section on the right, actually the right half. Looking at the channel 1 input, you have a little VU meter there, minus 10 dB, minus 30, minus 20, minus 10, and then 0. The bottom three, that's the minus 20, minus 30, minus 40, are green, and those are considered to be good, so you always want to have the signal in that area. The minus 10, that's the second one from the top, that's amber, so you're expected to be hitting that from time to time, but you still have some headroom. If it illuminates the top LED, the 0 dB position, that's indication of clipping, that after the analog to digital converter, you're clipping the signal, so you're losing data at that point. You do not want to have that top one illuminate at all. You have to back off on the gain if you are illuminating it. Those apparently are fed back from the computer, not just a simple bar graph LED arrangement on the analog signal. I believe it's fed back from the digital side, at least, if not from the computer driver, then from the digital side of the conversion process. If you have a microphone plugged in and it's a phantom power microphone requiring 48 volt phantom, then you push that left button that has a red LED under it, and the LED will illuminate, showing that phantom power is being applied to the microphone. If you're going to use a line input instead of the mic input, basically if you want to bypass the internal microphone preamplifier for that channel, then you push that middle button that's labeled line, and the green LED under it will illuminate to show that you're now listening to a line level input, not the microphone. And then finally, if you desire a high pass filter on the input, then you push the right button, which has a little simplified graph of a low cut or high pass filter envelope, and again there's a green LED to indicate when you're in that mode. Then you have your gain control that does apply to both the microphone preamplifier and the line input. If you're in the line mode, you have 27 dB of gain, and that's again adjustable by the gain control. If you're in microphone mode, in other words, if you're not in line mode, then the preamp gives you 64 dB of gain, once again adjusted by the gain control for that channel. Essentially what the line switch does is it bypasses the microphone preamplifier circuit. So you go directly from the input jack to the analog to digital converter, instead of going from the jack through the mic preamp and then to the analog to digital converter. Of course, either way you have the gain control in the middle of that. Each channel also has a button marked 4K, which is probably of limited usefulness. This is essentially a very high spec A to D circuit, and D to A come in the other direction. But as far as bandwidth and noise and clarity and other hi-fi specifications that you might be interested in, sometimes you don't want that, and by pushing that button it takes the analog portion of the circuit and makes it behave more like a vintage mixing board mic preamp circuit would, for example, with certain attenuation and boosting of various parts of the audio bandwidth. Makes it sound a little more vintagey. So if you happen to want that, you could push that 4K button. It doesn't have a separate LED under it like the upper buttons. Instead, the whole button lights up. It seems like a fancier button for a limited usefulness feature. I just want to reiterate that for the two inputs on the right in this image, if you're using a microphone, the instruction manual says that you must use the XLR type plug coming into it. And if you're using a line level signal, you must use the 1/4-inch phone type plug coming into the middle of the jack. You can't rig it up to have the microphone going in through the 1/4-inch and vice versa. So you might need to use an adapter if you have a line level signal that is XLR, or if you have a microphone that's using 1/4-inch phone. And if you have some other type of device, again, I already mentioned guitars, electric basses, things of that sort, you know, theremins, whatever, and it's got the usual high impedance and the signal levels typical of those pickups on those types of electric guitars, then you definitely want to use the instrument inputs on the front panel. If you have something like a synthesizer, depending on the type of output, sometimes you should use the instrument inputs. Sometimes you should use the line out input around the back panel. It depends on the type of instrument. And I didn't think the user's manual was terribly useful in this one detail, and I haven't tried it myself, but I believe that plugging an instrument into one of the instrument jacks essentially disregards the other settings, such as whether you have the line button pushed on the front panel and things like that. That it's automatically treating it like an instrument input because you've plugged something into one of those front jacks. And I'm being lazy and I haven't gone back to check if I said it already, so I'll say it again just for good measure. If you're plugging something from the outputs here into other equipment, they're really intended to go into monitor speakers, something that has its own amplification associated with it. This is obviously not a speaker output, these left and right jacks on the rear. But of course you can plug these outputs into, you know, recording equipment. You can plug them into, you know, a set of powered computer speakers. You can run them into a mixing board. You can do all sorts of things with them. They are line level signals. And here's the more important point, is they are balanced outputs. So they're expecting a tip ring sleeve or TRS style 1/4-inch phone plug for each of those. And that's necessary for the ground and then the 2 wires for the signals that are associated with a balanced line level output. If you are not using a balanced line for whatever these outputs are going to, for example, if you're just going into single-ended equipment, not equipment with balanced inputs, then you can use the single-ended stuff, and that means you're going to use a tip sleeve type 1/4-inch plug, not a tip ring sleeve. So in other words, the kind of 1/4-inch plug that only has the tip connection and then the rest of the connection. There's no middle ring. These outputs are designed to handle that. It won't damage them. And in my case, since I'm using the outputs to go to a set of powered computer speakers, I needed to use an appropriate cable. So for my application, I bought a factory-made Y cable. This is made by HOSA in California. It's their model HMP006Y, Y presumably meaning Y cable. It has 2 1/4-inch phone tip sleeve type plugs. That's at the upper center of the picture, and then it goes through the Y merger and then goes through a cable that ends at a 1/8-inch tip ring sleeve plug, and that's the kind of thing that you would want to have for connectors the size of powered computer speakers. Now in my case, I got the male version as shown here because I always use a female-to-female coupler, allowing me to quickly disconnect the output of my sound source from the powered computer speakers, because sometimes I quickly plug them into little handheld digital recorders in order to listen to the output of those. I want to be able to quickly unplug it without reaching around the back of the computer and things like that. Otherwise, I would have got this same cable with a female 1/8 inch tip ring sleeve socket instead of a plug. So if you were to buy a similar cable, make sure you get a version with the female end instead of the male end, as I did. The whole right side of this panel is dedicated to monitoring one way or another, and that basically is influencing the output of the headphones and the output for the monitor jacks on the rear panel. The big knob is for the monitor jacks. The small knob at the lower right is for the headphone jacks, both of them. They have a common volume control. But although I haven't actually tried it, the instructions say that the monitor knob does not affect the headphone level. That may or may not be true, but regardless, it's primarily there to control the volume of the signal coming out of the output jacks on the rear panel. Now there's an additional knob at the upper right here, and that is the little mixer, essentially. If you have the knob turned, the mix knob turned all the way counterclockwise, it has the word input there. What you're doing is you're listening to the analog signal before the analog to digital converter. So the raw signal without any processing other than, preamplification and gain. If you turn that mix knob all the way to the right, you're listening to the digital signal coming out of the analog to digital converters, and possibly after it's already gone through the USB cable and into the computer and then bounced back to this. I'm not sure about that part, but certainly after the whole digital part of it has done its thing, and you can expect that there might be a small latency with that. If you turn the mix knob to anything other than full counterclockwise or full clockwise, in other words, listening to the pure pre-analog to digital conversion or the pure post-digital processing, if you move it anywhere in the middle, you start getting a mix of those two signals. And that example, for example, if you set that to the 12 o'clock position, you'd be listening to 50% of the input and 50% of the post-processing output, essentially. And if there's any latency, you'd be able to hear it. You'd hear, both the input and the processed version laid one on top of another. And that can be useful in certain situations. The way I'm using it, just as a simple sound card, I've got it adjusted to the output, although, because I'm trying to listen to the signal that's coming from the computer, not the signal that's coming in through the input jacks. As long as the computer is there, of course, they're essentially the same signal. Finally, the other thing on this panel is the small button to the left of the mix knob, and it's labeled stereo, and there's a green LED under it. The way this works is for the two input channels, if you do nothing else, those signals are treated as monaural signals, a mono signal on channel 1, a mono signal on channel 2, and those signals are both fed equally to the left and right channels of everything that goes, after the preamps and so on. Therefore, you'll hear it, if you plug in a guitar on the front or a line jack or a microphone on the rear jack, you'll hear that signal on both the left and right monitor outputs. And there's no adjustment here for whether it should be faded one way or the other. It's just equal, both output channels, or both left and right. If you plug in stereo signals, however, in other words, you have something where you're really trying to treat channel 1 as left and channel 2 as right, and you don't want those to be mixed with each other, you want them to stay separate left and right, then you push that little stereo button, and it changes the way this works where, you know, channel 1 is left and channel 2 is right, and they stay as a stereo signal all the way through all the processing. So that's useful. It's confusing to me that they put it next to the mix knob, because I don't really think it has anything to do with that. More information on the rear panel. The monitor outputs, that's the two jacks labeled left and right here. Those are, as I already said, they're balanced output signal types. More importantly, they're DC coupled, so there's no series capacitor in there. And that's important because an auxiliary or ancillary feature of this unit is if you're using appropriate software on your computer or your digital audio workstation or whatever you've got this plugged into, it's possible to treat this as a box that allows control of equipment that uses control voltages. So it's actually a DC output plus or minus 5 volts, I believe it is, that if you plugged it into certain kinds of synthesizers, one of those could control the note that's being played, and the other one could be used as a gate, for example, to either start a note or stop a note, or perhaps control the attack, decay, sustain, release of a filter or a envelope, a volume envelope on a synthesizer, other things like that. So those output jacks can be used for this other purpose besides just audio, and you have to have appropriate software again to make this behave that way. But for them to behave that way, they have to be DC coupled. And normally that isn't an issue even if you are using it for audio. It's just a feature to point out. Another thing that occurs to me to mention about the front panel is that according to the instructions, the input jacks have a auto detect feature per input, so each one can be different. It's also referred to DI, or referred to as DI, and it's essentially detecting if you've got a guitar or a bass plugged in there or some other kinds of instrument circuits plugged in, and it has to do with level and impedance matching. So for the most part, it's able to do that without any additional selections by the user. Okay, I'm just going to rattle off some other specifications and technical details, and I'm just showing some pictures of the panel with some LEDs lit up here. The device can be used with Macintosh OS computers or Windows-based computers. If you're using it with a Mac, then there is no driver needed because it's class compliant. However, if you're using a Windows computer, you must use the specific driver from Solid State Logic for this particular device. It won't just work plug and play. You have to use the driver. The analog to digital converter and digital to analog converter is 32 bits, 192 kilohertz. Although you can program the actual bit depth and sampling rate using the control panel, which is installed along with the driver. It's just accessed through this part of the screen on your desktop. There's a tab for selecting the sample rate, and it defaults to 48 kilohertz or 48,000 hertz, but you can also set it to 44.1 kilohertz, 88.2 kilohertz, 96 kilohertz, 176.4 kilohertz, and 192 kilohertz. It's also 16 bits, but I don't see any place to adjust that on the control panel. Here are quick views of the other tabs. You can assign the ASIO device. You can mess with the buffer settings. here's other info on the unit and the revision of the firmware, I believe it is. And by the way, apparently you can flash firmware revisions from files you download from the website and then get them into the SSL2 to update the firmware revision level, but I haven't tried doing that. At least on Windows installations, it is necessary to individually select in Windows control panel under sounds. There are settings for the input device, playback in other words, or that would be input, that would be recording, and then the output, which would be called playback. Different versions of Windows might call them different things, but there's separate adjustments for each one, and each one you have to go in and tell it that you want to use the driver for this device instead of whatever it may be otherwise. Otherwise, this thing will sit there fat, dumb, and happy, and it'll never communicate with the computer. It's also possible to set up just this thing as the input device and use your regular computer's analog output to drive speakers, for example, or you could use both the input and the output features of this. Again, that's selectable, but you select it primarily in Windows in the control panel, and possibly also in your digital audio workstation or whatever audio editing software you may be using it with on your computer. The user's manual, which you again have to download from the website, you can choose to print it out or not. I always print out my manuals, and I have it wire bound here. Make sure you get the version that matches your particular device. I found that there was not a manual for the SSL2 Mark II. The one I'm showing here is the SSL2 Plus, which I initially printed out before I realized it was not the right manual. And they actually didn't have a PDF that you could download of the one that matched my device, so I had to request that from tech support, and they probably have updated the website now, I don't know, but they emailed me a link to where I could download it. But again, it's very peculiar. They want you to log into the website and everything, as if it's a high security thing in order to just get the manual. But, they must have their reasons for it. Anyway, it's a pretty good manual. It covers a lot of things. It covers installation for both Windows and Mac. It talks about setting up your software to make sure it's properly configured to use this. It has, detailed information on inputs and outputs and then various control settings and so on. And it doesn't seem to leave out very much. There were just a few things I had to ask from tech support to make sure I understood it correctly. Out of curiosity, I opened mine up. I had to remove 4 screws on the top panel and 4 screws on the rear panel because they come out as one part. You can't move it very much because there's these very short ribbon cables going from the main circuit board, which is attached to the rear side of the top panel. The little ribbon cables go down to 2 small sub-circuit boards, one for the headphones and the other for the instrument jacks. And you can see that pretty clearly here. There's some large-scale integration on the circuit. It's fairly complex circuit board. This is a closer view of the main circuit board. You can see that the microphone/line input jacks and the 2 output jacks are part of the main circuit board. There's obviously additional jacks to the left of the main ones. That's where the MIDI jacks would go if this was a 2 plus instead of a 2. And there's also positions on the board for 2 additional jacks that are, I don't remember what they're for, but there's something that the 2 plus version has that this version does not. So obviously they have a common circuit board for all the versions. And finally, here's a closer view of the 2 sub-circuit boards. I don't think there's a lot on those except just converting the ribbon cable to the jacks. I didn't spot any electronic components on them.